traditional classroom. Usually what we will cover is actually the content delivery during lesson, and then the concept, the engaging of the concept, what they have learned, is actually given as homework for this class. So basically for that particular lesson, what they have done is actually given the content at home to read out, and then it can be at their own pace. So if the girls are slower, they can actually read it a few times, discuss with their friends. So basically, and then when they are back in the classroom on that particular day, we have got more time to engage in discussion and also for activity to enhance the pre-class reading. When you read the two articles, the article actually used metaphor of family tree to depict periodic table. What the article actually mentioned, if let's say in my family, who is in my family? My parents. Okay, my parents. Who else? Let's share. Okay, your group. And then the rest listen.
The metaphor or analogy that our group chose was the spider web, because he said that like all the elements are linked somehow, and I would mention that they have a pattern, and even though they're not directly connected, they are still linked in some way.
Our group chose like a supermarket, because like supermarket all the food is like categorized into different kinds of food, and they're like it's really easy to find what you want.
Okay, thank you. So they are metaphor and analysis supermarket. So when you go to supermarket, you know where to go for the groceries, where to go for the dairy products.
Aeroplane.
Aeroplane, okay. First time I heard of aeroplane, okay. Yeah, okay, good.
Because aeroplane has like business class, economy class, and first class.
Oh, you went for me.
And so like no matter what, they're all interconnected, and like the people are still in the same page, and so they still have the same quality stuff like that, but they're all in different classes.
Okay, thank you. So aeroplane has got different classes, alright? So based on all these analogies that we have shared in the class, at the end of this lesson, let's go back to all these analogies and see whether we have got anything you want to ask. Okay, basically for the two readings, we actually went back before the periodic table that we are currently doing. Before Mendeleev actually go get the periodic table, the one that we are currently using, there are other people, characters involved. So what about the laws of triad? For those who have read, can you share with the class?
It's like the element in the middle is like the opposite is the mean of the element.
Okay, good. So before Mendeleev time, Dobereiner actually came up with this. He also has got some pattern, he call it law of triad. The element right in the center has got some pattern. It's actually the average of the mass, atomic mass, is the average of the other two in the same group. The people then, the science students that actually followed this. However, as more elements are found, he cannot fit in the elements. So this one doesn't work anymore. The next scientist that you read in your article is actually John Newlands. He came up with these laws of octave. That's this table here. What is slightly different from the periodic table that we actually currently are using now? The noble gases, noble elements are not that good. What else? Third one. Okay. There isn't a G. Beryllium in our periodic table is written Be, right? But down here is a G symbol. What else? You all realize that some of them have got two elements on it? Will there be two elements with the same mass? No, right? Okay, so there are limitations, and for Newlands, when there are more elements found, you also find that it's difficult for him to fit in the new elements. Alright, so we have got these two scientists, and for today, all of you are going to assume the role of Dmitri Mendeleev. This is a periodic table that we are using, right? From this moment onwards, I do not want to see any more periodic table. Don't open up your laptop. Every one of you in your group is going to be Mendeleev. I'm going to give you a stack of cards. Alright, I'm going to give you a stack of cards. Inside this stack, they are all elements. During Mendeleev's time, he also had all the properties of the elements, so he was trying to put them in some order. So all of you are going to be Mendeleev. You are going to assume this role. Each group will be given a set of cards. You are going to discuss with the information of the elements given, arrange them in some pattern. Don't follow the periodic table that you already know. Try and be creative. If you can arrange it in different ways, arrange it. Alright? Predict that inside there's one particular element that is unknown. During Mendeleev's time, he also had got one element that nobody knows. So what we need to do is put this somewhere, alright, and predict the properties of this unknown element in the Google form that I provided in the MODO later on. Alright, at the end of it, take a picture of the arrangement, upload this picture and also your explanation of the one in your group. So what are y'all arranging the elements now? Under I. Okay, so now metal, semi-metal and metal. So now after that will be I. Okay.
We can't arrange it all in one row.
Yeah, I know, but it's already.
Why can't you arrange it in one row?
Because it's one is okay, you need the whole project sheet to arrange the whole thing. And then it's like only 3 rows. It's kind of disgusting. Table is
If you want, you can make use of the whole 3 tables. If you want to join tables, you can carry on, alright? So how many elements are there? 7, okay. Yeah.
All of them must be
very nice, right? Yeah.
That means it must be 4 in a row. 1, 2, 3.
Yeah, but doesn't the
So now, are you trying to group them according to their reactions with water?
Yeah.
Okay.
Which kind of fail?
If it fails, then why don't you try explore other ways of putting them there, right? That's what Mendeleev actually experienced also. When you put them it fails, try again. Metal, non-metal, or iron. Okay, so now you have got to try the test again. If you find that this one doesn't fit there, good, if non-metals are all there, is it? Okay, so if you are arranging by IE, so where can this one go to? As you have found the arrangement, now what if new elements are being found, you have got to try to find the pattern. If new elements found and then you cannot fit in this one, it's not valid lah, your pattern, right? Okay, once done, where is the unknown? They give you some clue there, isn't it? Located below NN. So where's NN? It's here. Okay. It is actually known now. All these are actually I of certain elements in the periodic table. Yeah, they are. These are elements. We just took away the symbol and give them the unknown symbol. So, okay. Done your pattern. inquiry based, you are given the properties of the elements. Properties of the elements. All these elements are the properties are the exact properties that the element actually has. These are elements from the periodic table. What we did was just take away the name of the element and put in an alphabet to that element. Alright? So all of you have got certain pattern. I need you all to upload and explain.
Okay, so our first photo is according to using atomic radius. Then we couldn't find any other patterns in it, so we changed it to the second one, which is according to the increasing electromagnetic.
So the first one when they did atomic radius, then they cannot find a good explanation of the pattern. So they change it. Yeah.
So from these two pictures, then we came out with the different properties. Like we just compare like the one in between, like I know this in between like this one and that one, for example. So we just compare like for certain properties we average the numbers.
Do you all get what they are trying to say?
Like for the properties of numbers, you'll find the number before the unknown and after the unknown, and we just average it. And then for the state, we found that it went from solid to liquid to gas. So unknown is solid.
So they actually found a pattern. They found a pattern that there's a pattern from solid, liquid to gas. Their way of averaging it is just like the one that the triad, the laws of triad.
I mean, I'm not sure about the two of you, but it was quite fun for me. As in, like, it's quite interesting to rearrange the periodic table and stuff. Yeah. Yeah. But then, like, other people seem to be getting frustrated. So it depends on who you're doing with. If you're like sort of right, or if you're like people who's better with organizing stuff in your team will be quite fun. Like, if you're just horrible at arranging and stuff, then you practically die or be a people that's going. Yeah.
You have to like break out of, because we all used to having periodic tables, so you have to like break out of that mindset that it should be arranged like this. And
but we don't even know what element it is.
Yeah, but because you can sometimes you can sort of guess because they give you the atomic mass, and if you remember it, and then some of them you can sort of work it out, but because you have to see that the point is not trying to recreate the periodic table, but to just, it's like when you try and you take something that's already been done, but then you break it down and then you try and put it together in a new way and you see whether it works or not. Like, you could say reinventing the wheel, but in a way that it will like allow you to see why it makes sense that it was built that way. Like, you recreate the periodic table, you realize your own one is kind of and then so you see and you get to realize how the real periodic table is actually quite amazing that they actually managed to get it in such an orderly manner.
I find that a bit more difficult to follow, especially when there's no visual. Well, personally, I like hands-on activities. I find them more engaging and they stick in my mind longer. Whereas sitting down and looking at the teacher talking
basically, what you realize for that particular lesson is actually we make use of the technology for the reading part, for the pre-classroom part, and then through activities for them to enhance the learning that we actually wanted to bring up during that lesson. So for 311, for that particular lessons, the thing that is good, find that is positive is actually the girls are actually more interested and they are more ready to engage in activities and they know what they are actually learning.